surrounded by darkness. Open your eyes. Look around you. It's a beautiful life. Don't waste time. Open your mind. Have no regrets. Paint the sky your favorite color.
Hello, hello! Welcome back to CodeLabs. We are now on day 3, very first week of CodeLabs, and we are going to be talking about hacking. And I don't mean in the term sense of hackathon, I mean in the sense of trying to figure out how to break web applications, desktop applications, all sorts of things. Really just trying to understand how things work and how we can use the way that they work in ways that they maybe weren't exactly intending. So we're going to be talking about hacking. Obviously, it's somewhat questionable if you want to do this to people, web applications, whatever else that you don't own. Some companies do have programs that allow you to do that, that are called bug bounties, where within certain conditions you are allowed to do that. What you would want to do, if you want to look into that, would just be to search for a name of an organization, like let's say SR&D, bug bounty, and well, for us it doesn't come up. But if you actually scroll down to the very bottom of our website, we actually, for example, do have one. And so if you want to try to find bugs in our software, then you are welcome to do that as long as you stay within these rules. And in fact, most organizations do have something like that. Most modern web-facing organizations do have something like that. But if they don't, be aware. This is just my disclaimer starting off. If you are messing with people's systems that you don't own, control, or have some sort of association with, if they haven't said it's okay, don't do that. That is bad. With that in mind, we're going to actually today go through some of the some questions that we set up for a thing called Code Cup, which some of you might be familiar with. It's a sort of a cybersecurity challenge that we do every code day at usually around 6 to 7 p.m. Pacific, where all the different cities compete against each other to solve as many problems as possible in the shortest amount of time, or sorry, within an hour, which is a short amount of time. And try to solve a bunch of cybersecurity problems, and they range from very easy to very advanced. We're going to go through some of those problems today, and just some of the historical ones, and just use them as some real-world examples of how you might be able to break programs, web applications, so on and so forth, that you might not be familiar with. So we're going to go ahead and go through that. If you have any questions throughout the thing, feel free to chime in on the Twitch chat. I got this fancy little thing right in here now where we can even see the questions if we need to. And then we are also going to, if anyone has done Code Cup in the past and there were any questions that were really sticking in their mind and that they haven't, that they don't remember the answer to, feel free to post those in the Twitch chat as well. If there's something that's still stuck in your mind where you're like, how do you solve that problem? We're not going to be able to go through all of them today because I think in total there are well over 250 questions that we've had in the past. So, we're not going to be able to get through all of them today, but we will be able to get through a lot of the ones that are sort of representative of hacking as a whole and ways to do things. So with that in mind, I'm going to go ahead and come back to the computer screen, and we are going to look at some of the problems from previous code cups. So this was from winter 2018, and we're going to start off with a really basic one, which is decompiling executables. So if we were to go ahead and download this, which I think I have actually already downloaded, and I'm going to use Linux. Yeah, I already have this downloaded. I'm going to use Linux. Most of this stuff will apply to Windows, Mac as well. There's a few commands that are easier to do on Linux, perhaps, than they are on other ones, or on Mac. Windows will be a little bit more difficult. But I'm going to go ahead and use Linux anyway. So first of all, when we're talking about executables, right? An executable is something you can run. This is an exe, which is a Windows program, but I can run it on Linux with a command called mono. And you can see it just says nothing to see here, move along. Which of course means that there is absolutely something to see there, because no one would write something like that otherwise. So we're going to go ahead and see if we can figure out what in addition there is there. So a really good place to start when you're looking at executables, obviously if you were to just edit them in a text editor, yeah, it's not the most useful. That's not the most useful thing in the world, right? So what can we do to be a little bit more interesting? Well, you can see actually there are a few things that you can kind of see in here that look kind of useful, right? They look like text. And maybe there's something in the text that we could find helpful. So a helpful program for doing that is actually just, it's called strings. And if I were to run strings on this program, you would see basically every string that's longer than a few, any instance in which there are more than a few letters in a row. Because again, executables are binary. So most things in an executable are probably not going to just coincidentally be text, but some of them will. And so whenever we see more than a few letters in a row, we can just print those out. Now in this case, there's not actually anything super useful. We can see that it is for CodeCup. It looks like it's for Alberta on CodeCup. There's a few things that are generated by what looks like C#, which is going to be interesting to see as well. I'm going to double check that that wasn't anyone complaining that the stream is broken, which it doesn't look like it was. So it does look like it's C#, and the reason that I can tell that is because you see these system.runtime.compiler services. That's the way that C# would write things. If you saw things that looked like Java, you would probably notice that it was a Java program. And so while we can actually use this directly, well, we can actually decompile it into machine code, basically. That is something that we could theoretically do. That's not going to be the way that we're going to do it, because we know it's C# and we can actually do a little bit better. So C#, Java, a few other ones like that. Python is another example, and I think we might even see some examples of that later. Are three examples, just off the top of my head, of programming languages that are compiled, but are compiled into some format that can actually be really easily decompiled. Java, for example, it's literally a zip folder. If you rename a jar to .zip, in most cases, you can actually just open it, and there will be a bunch of stuff inside. C#, there are a bunch of programs to decompile them. And so what I can do is I can search for .Net Decompiler. There are a bunch of these that are already on, that are online. There's one of them that you can actually use in the web browser. And there's one of them, there's a ton of them that you can download for free. I actually have one downloaded already. I think it's called NetDis. And then I'm just going to run it on this thing. And you can actually see, this isn't quite what C# code looks like. C# code looks a lot more readable. But you can see that it produced something much more readable than the binary text format that we had previously. So if I actually scroll through this, you can see actually right here where it's saying, nothing to see here, move along. It's loading that into a string, and then it's calling system.console.writeLine on that string. And then somewhere else down here, there is this separate method. And it looks like what it's doing is it's calling load string, and it's setting the flag to this string. Now, I don't really know much about the format that this, Dotnet Decompiler is producing. They'll each produce slightly different formats, but it looks very clear that this is probably the flag. And in fact, if we go back to the answers, you can see that that is actually the flag. The reason it didn't come up with strings, by the way, was because we put a space in between every character, which is kind of a clever way of getting around that, because then what you would need to do is run strings and get every single character. You'd have to run strings and ask it to print out every single thing that has at least one character, which is just not as reasonable. It's just not something that we want to do. I'm going to go ahead and just really quickly move this over here so I can see what's up. Cool. Okay, so that's one of them. That's decompiling things, and that's also, again, strings, which is a good place to just start, because sometimes they'll just have things in executables. I think if I can actually find some other ones, let's see if we have any that use strings. There's another Python one. It looks like we don't have any in here that use strings. What about over here? No, okay. Sometimes that'll work. In most cases, it won't. In most cases, it'll be a little bit more complicated. We also had another one down here. So there are a few Python programs that we had in previous instances as well. And those Python programs, there's also Python decompilers. Python decompiler. And yes, there's a thing called uncompile. So that is also an option. And again, for Java, there are options as well. In general, you're going to want to search for just the name of the thing you're using plus decompiler. You can probably come up with examples. In more complicated cases where something is written in something like C, C++, assembler, or is using a language that doesn't compile in quite as easily of a reversible way, you can actually do things like, you can use like debuggers and a whole bunch of other stuff. I think there's a thing called IDA debugger. I think that's what it's called for Windows. That's really good for reverse engineering what's going on. However, that said, it is a little bit more complicated to use for a beginner versus something simple like this. So really, anytime you have an executable, those are some really good steps to go through. Use something like strings, use something like decompiler if you can figure out what it is that it's made in, or even just try a bunch of them if you're not sure. And then also on that note, that'll also work for things like zip files, PNGs, JPEGs. Quite often, anything that's a binary format, you can just hide things in it randomly, but something like strings will usually figure it out. Okay, so let's go on to this next one. This one is actually really interesting as well. The answer is at the head of Florida, so what we're going to do is we're going to go down to Florida. Here we go. There's a website here. This might take a second because it's hosted on Heroku, and so it'll take a second to start up. And while it is doing that, I'm going to see if I can get this server to quiet down, so one sec. Perfect. Okay, so this is the dancing baby. This was the GIF to have in like 1995 on your website, so it's kind of a joke. But let's go back up to the question that we were looking at originally. The answer's at the head of Florida is the hint text, and of course we know the answer. So here's something that you might not have known. Many of you might be familiar with the fact that there is HTML. This is very beautiful 1995 era HTML. You may be familiar with the fact that there is some HTML, but one thing that you might not be familiar with, hopefully you are, but maybe not, is the idea that web browsers actually send more than just HTML. They actually send more complicated stuff. Yeah, CSS is absolutely overrated, as someone pointed out. Why use CSS when you have this? There are good reasons. Websites actually send more data than that. And actually, let's go ahead and let's try that out. So if you're running an older version of Windows, or you install this, or you're running Linux or Mac, there's a program called Telnet, which is basically just connect to a web server and allow you to type in text. And we're going to use example.com, which works. It's an example website. We're going to use that solely because I know that it doesn't require HTTPS, which you can't use Telnet for ones that use HTTPS. But we're going to take a look at what an HTML web request actually looks like. So if we want to get... you can't really see the bottom of my screen, can you? Is that anything I can fix? I don't think so. Let's do this. We'll open another window, we'll put it at the bottom, we'll bump things up a little bit. Cool. So what we're gonna do if we want to get a website from, example.com, when we visit example.com in our web browser, what we're actually doing is we're making a request like this. Our web browser is literally connecting to this web server, and it's sending as text, I think it's http/1.1 get slash, or maybe it's the other way around. It might be get /http 1.1. There we go. And then the other thing it's sending is host example.com. And then it sends 2 enters, and then we get back the HTML. And that is literally how it works. So again, just as an example, we connect to example.com, which is a computer somewhere. And we type, literally, get, or what was it? Get, I don't remember what order we did it in previously now. I can never remember the order between these two. So let's try it again. Get /http 1.1. Cool. Host example.com. And that's really all we need to send. We send 2 enters, and it returns back all the HTML. But it also returns these things called headers. HTTP 1.1 200 OK. If you've ever heard of 404 file not found, that would actually change right here. The web server would say 404 file not found. That is literally it. If you've ever heard of a post request, by the way, what is happening is that instead of saying get, it's literally saying post. That's it. It's that simple. So when we're actually talking about, things like get request, post request, 404 file not found, all that, it's not actually that complicated. It's literally just changing some text somewhere, which, by the way, is how you can write your own web servers that don't just serve static HTML. But in this case, there's all these other headers around the response as well. So it's got like a cache, how long you should store it before it, you need to make sure to refresh it, when it was last modified, some information about its own cache, the content length, which is how long the page is, a cache that I have locally, and a few other things as well. That's true of all websites, and an easier way to do it is to actually just right-click on the website and click Expect Element. And then we go to the Network tab, we go ahead and hit Reload, and we just click on this. And I know it's a little bit hard to see. Let me see if I can switch over to just showing you the screen. Over here, we have all of the response headers as well as the headers that we actually sent with our request. And you can see that there is one header that says XBC flag is yo. And so that is actually where our flag comes from, and that's understanding headers. Now there's lots of information that could be in headers in more of a useful case. Obviously that's not going to be super useful in the real world, right? Because most people are not going to put sensitive information in headers. But people might put information that they think is sensitive in headers, which is actually where this can come in handy. And so sometimes, for example, someone might put information about their web server in headers. That's super, super common to list out what the web server version was. Well, what's the problem with that? If people are running a slightly older version of a web server, maybe there's an exploit that you can just run that's known. There's a known problem with that version of the web server, or a known problem with that version of the operating system, or their programming thing if they're using something like PHP. In many cases, there are known problems with those. And so what you can do is if someone is in their headers sending you their web server version, you can actually go and search for that and just search for exploit or bug and see if you can find something about it. Now, how are you going to actually exploit those? Sometimes it's more complicated, sometimes it's less complicated. There's a really great tool for exploiting these bugs more easily called Metasploit. And you can actually search for that online. Metasploit. I'm going to see if I can use Chrome because Firefox is not letting me zoom in for some reason. There we go. So we can use something like Metasploit. And Metasploit is a really great tool that just basically has a database of built-in exploits and programs for exploiting all of them. And so that would be a cool way to, for example, if you found out that someone was running a vulnerable web server, find a way to fix that. So we're going to go ahead and go back to our thing. We'll take a look and find some other ones. Let's see if we can find a few more interesting ones. Here's an example of a program that we would have to use a debugger for. I'm just going to briefly show you how it would work. We're already in downloads. So we could run, this is a Linux thing. We could run this program, and it just says please wait, and for anyone who's interested, it will never end. Again, we could run strings, see if we find anything useful there. And you can see that, again, it was a little bit tricky about this. Your flag is, but it never actually prints out the flag. And again, there's a reason for that. People can sort of get around strings. But we can actually run GDB, which I apparently don't have installed. So let's see how fast this goes. It's taking a little bit longer. We'll go ahead and cancel that. But theoretically, we could run GDB on this program because just looking at it with strings, it doesn't obviously look like it's Java or anything else. And in fact, I think this was written in C++, because I think I wrote it. Yeah, and we could actually see the original file here. The problem with things that aren't written in something like C++ or Java, let's do this in Chrome actually, where we can see it. The problem with things that aren't written in C++ or Java is that we don't actually get access to the source code ever. You can actually see, for example, here's how we're doing it, where we're avoiding the strings, is that we're actually printing each one as an individual letter, but we're storing them as numbers. So what we would need to do is we would need to use something like GDB, which allows us to actually basically step through line by line. And what we would theoretically be able to do then is change, it says while waiting is the code that's actually causing it to wait. And waiting is always 1. And so what we could do with something like GDB is set waiting to equal 0. And then it would actually skip over that and continue to run. That would be one way to do it. A little bit more complicated. Wouldn't necessarily recommend something like that if you're a beginner. That's also why it's worth 75 points. In Code Cup terms, that's a medium to slightly advanced problem. So we're going to skip over some bytecode stuff for right now. We get some JPEG things. Georgia, that would be a good one. Here's another .NET one. So we can take a look at this. So it's arkansas.exe. If I were to run mono, you can see it prints out something. And it actually reliably prints out something, which is a good sign that we might be able to do something with it. So again, what we're going to do, we'll decompile it, and we'll see what's there. And oh, look at this. Code Cup program password. And it's that. Plus something else. There's some other stuff going on here too. But we can actually see that there are, and it looks like this is a whole encryption program and everything else. But if that's the password, then theoretically somewhere in here we have the flag that's actually being encrypted. So we're calling simple decrypt with password. Result, where do we see write message? See if we can find anything in here that might look useful. This is the password. So this is the password. Okay, so I see what we've done here. This was a while ago and I don't remember writing this. So what we've done here is actually, it says this is the password, what's next though? So we actually have the password. What we would need to do then is, theoretically with strings, we could actually find this password. I don't know why, was that Arkansas that we just ran? I'm actually not sure why it didn't come up, but in theory with strings, you should be able to find something like that password. But the problem is that we actually need to know the encryption routine as well. And so what we would do is we would compile this, we would decompile this, get the source code. We'd probably do it in one that gives us just C# code rather than whatever this thing gives us. And then we could actually just run the program to decrypt it, knowing the password and knowing the output, which again is this whole thing. By the way, one other thing that might be useful, whenever you notice an equal sign at the end of a string, that is usually an indication that it's something called base 64 encoded. And you will see this very often, particularly where you might have something where it's got like binary, which this thing does. An encryption routine actually usually produces a binary output that'll just be a bunch of gibberish if you just try to natively print it. But you can do lots of other things with base 64 encoding as well. And base 64 encoding does not require a password. There's nothing complicated about it. It's just a format. So again, we'll use Chrome base 64 decode. Go ahead and kill my chat program. I'll go ahead and paste this. We'll hit run, and we can see again. Well, you probably can't see, so let's zoom in. This is just a bunch of gibberish. Not very useful at all. That's kind of what we were expecting with this. But in some cases where you see something that's base 64 encoded, it might be a password. So for example, I could write out the password is Twitch chat. Let's say Kappa. I think that's a very Twitch chat thing to do. And I could actually take this into an encoder, paste it, encode it, and what we get is this thing. This actually doesn't have an equal sign. If we get unlucky, it won't have an equal sign. And if that's the case, then there's not much that you would be able to do. But if I were to add a few more characters, we'll probably end up with an equal sign at the end. If it has an equal sign, it's still base 64 decodable, but I don't know how you'd notice that it was. Almost anything with an equal sign at the end, though, is certainly base 64 decodable. And so we get the string that looks like gibberish, but we see it has an equal sign, and we're like, oh, hey, maybe this is base 64 encodable. We'll decode it. And there we go. Password is Kappa. So in some cases you'll see base 64 encoding. If you see that equal sign, it's a good indication that it is. If you don't see an equal sign, you could always try it. But I don't know what would be an indication there. I don't know how you would know that. Okay, here's a really interesting one. There's something on the site we don't want Google to know. There is no page listed here, so that's kind of a problem. Oh, why does it have the equal sign? That's a good question from the chat right now. So Zeke just asked, why does it have the equal sign? The answer for why it has the equal sign is because the way base 64 encoding works, it has to be padded to a certain length. And the character that they have chosen for padding is an equal sign. So there's nothing particularly special about the equal sign. It's just that the way base 64 encoding is set up, people have decided that the equal sign is what they will use to pad it out if it's not the correct length. No one else I know does that. So go ahead and go back to split screen. Unfortunately, I don't know what happened. Someone, it looks like, may have edited this and the website is missing. Colorado, I think these are all in the standard format though, so let's see if we can figure it out. Yeah, I think that this should just be Colorado because this is actually a really useful one too. Is it just here? Maybe it's just here. We'll see if we can figure this out. No. Okay. Well, that's unfortunate. I don't know what happened to the URL that was supposed to be for Colorado, and I don't happen to remember what it was because this is from like 8 months ago. But one thing that is generally useful is this thing called robots.txt. So we'll actually take a look at it and see if we can find one. I think we have one. We actually don't. It's interesting. Codeday probably does. Yeah. So robots.txt is this really interesting file that exists on lots of websites that tells search engines what they're not allowed to look at. Think about that. This is telling search engines what they're not allowed to look at. So it's probably a listing of very interesting pages that we might want to look at. So I don't know what exactly happened with that program, but you can see, for example, if I go to codeday.org/robots.txt, I can actually find out that, for example, CodeDay does not want you to look at any of these pages that are /disambiguation/. Now, in this particular case, it's not very useful to know that, because I happen to know, for an example, that the disambiguation pages are basically just pages that, like, if there's 2 events in Seattle, it'll tell you which one to go to. But in other cases, there might be more interesting ones. So let's just try a few other websites. What does Google not want search engines like Google to know about? Here's a really interesting list of a lot of them, right? Now, I'm pretty sure that Google, being a search company, as well as being good at security, is probably not going to have anything particularly bad in their robots.txt. I'm just fairly confident that that's the case. But there are a lot of things here, and they might be worth looking into, right? Like, just take a... Like, what is this? XFX7. Let's just go to it and see what's there. I got an extra slash. So there's nothing there, but it's listed in robots.txt, which is interesting, and that might actually mean there's something after it as well. Because robots.txt, when you end it with a trailing slash, like these ones, it actually will, anything matching that, anything starting with that, will go to something else. Really quickly, I'm just going to go back to Q&A. Gotta click on this. Go back to Q&A because people had a few other questions, which unfortunately, the way that this software works, it fades it out automatically, which is a little bit annoying. I don't know if there's a way to fix that. Fade is equal to, let's just try like 3,000. So at least in the future, it won't fade it out. Some people were talking about base 64. What does the term base 64 even mean? It means there are 64 possible values. So decimal is base 10. And you can say that because you can count, there are basically 10 digits, right? There's 0 through 9, which is 10 digits in total. Base 2 is binary. There's only 2 possible digits, 0 and 1. You can consider it as on or off, right? Base 64 is every single digit, there are 64 possible values. Now, obviously, we only have 10 digits that we're used to, right? There are only 10 digits that we usually use, 0 through 9. So where do we get the extra ones from? We get those from just random characters. And so we end up using a bunch of different characters, the lowercase and uppercase alphabet, as our 64 digits, right? So for anyone who's curious, that's what that means. You might have also seen something called hexadecimal. That is a base 16 system. And so for hexadecimal, what we're actually talking about is there are 16 possible values. And where do we get those? Well, it's 0 through 9, and then we need an extra 6. So we use A through F. Those are the extra ones that we're using as well. That sometimes comes up in challenges like this, something like hexadecimal. There are some other ones as well that are really unusual. There's one that's base 8 called octal. And then there's also some really weird ones. There's one that uses an imaginary base and some other things that are more mathy and not particularly useful. But just good to know. So that's answering that. And again, that is robots.txt. What are some other ones? Okay, here's actually a good one. So this is a really basic website. Oop, didn't copy it. We'll just copy it from here. So we get this really basic website. It asks for a username and password. I'm going to try test and test, and it's not actually going to work. And I'm going to hit cancel, and it'll say wrong. We are wrong. Very bad. Didn't get it right. What can we do here? Oftentimes, when you see a login form that looks like this, where it uses the web browser, and you kind of saw what it looked like on Firefox as well, right? It pops up like this. When you see something that uses one of those system login pages, technically that's built into the web browser. Technically, that is something that you can just, you can do it in Python or PHP or anything that's serving a website. You could technically do that. However, in many cases, what people do is they have a bunch of static website pages that are just in folders. And they want their web server itself to just password protect things. They're not using any fancy programs to do with logins. They're just telling the web server, I want to password protect it. And Apache, which is a really popular web server for beginners, I think somewhat misguidedly, because I actually think it's more difficult to use than other ones. But Apache has built in the ability to use this web browser style login form to ask for a login. And the way that you do it is you would put the login information in a file called .htpassword, HTPASSWD, and I know that you can't quite see that. So, what do we have here? We actually have a username and what's called a hashed password. Now, password hashes are an interesting thing on their own. People who may not have heard of this, let's just do a really simple example first. So let's go with let's go with MD5 online. MD5 is a password hashing algorithm. And what actually is a password hash to begin with? Let's see if we can do a simple example on paper. Give me just 1 second here. I think I can make this work. So we're going to do this on a piece of paper. And I think all I need to do is turn on the webcam. Audio did break. Audio did break. Okay, there we go. That should be a little bit better. My other camera is going to be in the background, but I think you should still be able to hear me now, so that's good. So let's say we have the string ABC, and what we want to do is we want to turn it into a format that's, if anyone gets the result, no one will be able to do anything with it. So that's what a password hash is, right? Like, what we want to do is we want to turn this to something such that knowing this thing, it's difficult to go backward. Why is that useful? Well, because it means that we can have something like where do we go? It means that we can have something like this password hash where we can see it and it's publicly exposed, which is bad, but it's hard to do anything with it. So it's a nice property to have. If someone were to steal our passwords, it would be harder for them to do anything with it because it would be hard for them to go backward. Here's a really simple password hashing algorithm that we're going to work out. Let's just say that, in the alphabet, A is 1, B is 2, C is 3, and so on and so forth. So what we do is we just convert each letter to its number form, 1, 2, 3, and then we add them. And we end up with 6, right? 6 is our hashed password. This is the hash, right? Now this was our input, ABC. This is our hashing algorithm. You might also just hear this called a function. But what this does is, this is the way that we do it, right? This is the method that we do it. We convert it to 1, 2, 3, and then we add them together, and we get this result 6. Now here's the thing, if we only know 6, if we only know that our hash is 6, and we know that the function that we used, A, B, C, 1, 2, 3, and then we add them. Oh, focus. There we go. If we only know those, we cannot go backward. Why not? Well, because 6 could be, right? Could be A. Could be B. Could be C. Could also be F, right? Assuming that this continues on forever. So we cannot go backward. But anytime we give it the string ABC, we'll always get the result 6 using our formula, right? That's effectively what a password hashing algorithm does. I'm going to go ahead and turn this off now. It's effectively what a password hashing algorithm does. It's just that that particular algorithm that we just described has some problems. And I'm not going to get too into what the problems are, but we wouldn't actually use it in real life. And so instead, we would use something a little bit more complicated. Now, one of the first ones that was widely used is a thing called MD5. Turns out MD5 has some problems as well. But what we can do for a lot of these hashes, actually, is we can just build a really big database of every possible password that's commonly used. And then just, again, because any single string, whenever we give the string ABC, we always get out 6, right? If we just make a list of every possible output and what the inputs are, we can actually just go backwards by looking it up in that table. And we call these rainbow tables. Now, the thing is, in real life, just like in this thing, one output could have multiple inputs. There could be a lot of different inputs. But the way that most real-world hashing algorithms work is that most of the inputs that you'll get are very unlikely. And people tend to choose predictable passwords. And so what we have is we have this table of common passwords to their outputs. And so, for example, if I have the password, terrible password, we get this MD5 hash. Now, technically, it's impossible to go backward, and we'll demonstrate this again later. But if I search for password hash lookup, say MD5, here's a website, super sketchy sounding website. So I run it because I have to check I'm not a robot when I'm using their robots to crack these passwords. Twitch chat, quickly chime in. Which of these are storefronts? I got this one, I got this one, I got this one, I got this one. Let's see if we're a robot. Okay, I think we're good. So we're going to paste in this hash, and we'll hit crack hashes. And we will get back... Actually, this one thinks that it cannot find it, which is funny because it's literally password. Oh, because we had a new line at the end of it. So we'll try this one. Not a robot. Just gonna find it. There we go. Password. Figured it out. I do not use crackstation.com frequently, or crackstation.net frequently. I just Googled this. Now, on the other hand, by the way, if we gave it a really complicated password that no one would ever come up with, I'm just mashing my keyboard here, right? I MD5 that, copy that, paste that here. It's the same length, by the way. No matter what length of input you get, you always get the same length of output for a hash. I hit crack hashes, it is not going to find it. Because it was just unlikely. It wasn't in their database. Yeah, it was. I know that's a really popular password, but unfortunately, it's not in their database. So that's kind of password hashes. Now, in this particular case, we know it's a different hashing algorithm. It's called SHA. What we can actually just search for even is probably HT password crack. And let's see. Okay, that's some. Other one. Okay. Well, we don't have anyone there, but we can do SHA crack online. Oh, and it's the same website. We'll see if this comes up with it. I think it's in a different format. Traffic lights. We need like a live overlay for voting on these CAPTCHAs. See if this comes up with it. So it doesn't recognize the hash format. So I think what's actually happening... By the way, do you recognize the equals sign? This is base 64 encoded. 64 decode. I think that what's happening is that this is in a weird format. So we're going to decode this. And yeah, we get this really weird thing. So base 64 to hex. Let's see if we can come up with this. Okay, here we go. We're going to set group by to none. So there are multiple ways of representing binary in a more useful form. One of them is base 64, which is one of the shortest ways you can do it in text. One of them is hexadecimal. And so this was representing, again, hashing algorithms are kind of like cryptography algorithms, so they tend to return bytes. So we need to turn it into text. They used this one. Most hashing algorithms are used to seeing it in this form, which is called hex. So I just searched for a website to do it online. We'll try pasting in this one. Storefronts. I don't think it's like a store rear. My mind has been uploaded to the self-driving car. Okay, so here we go. it figured it out, so that was what was going on. It's SHA1, and it's a common password, Hunter2, which is actually kind of an internet joke if anyone has ever seen it. So we'll go ahead, and now that we know that the username is admin, and we've cracked this hash, we can actually just type, what is it, admin, type that password, Hunter2, and welcome member, reminder, the flag is flag. This is actually one of my favorite. It's one of my favorite flags. It's just as good as the password, right? I mean, if you're going to have a really obvious password, why not have a really obvious flag as well? And so you type that in and you would get your points. Someone was asking for links to the thing. Let me see if I can just paste those in Twitch chat really quickly. Twitch.tv/srnd.org. Oh, not ours. I asked them if we could get that, and they haven't gotten back to me yet. Just like they've not gotten back to me about being partners. Or about being Twitch partners. So there's one. Here are some older questions as well. So we got 2 of them. The first one is the one that I've been going through so far, though. This has got explanations for all of them as well, very briefly. But we're not really going as in-depth in these explanations as we are here. We get some quiz questions. These are popular in Capture the Flags. What is the term for a lot of computers overwhelming something? It's a DDoS. You're going to have just a DOS as well. It's short for denial of service. This is actually really common when you have like a single you might have access to a web server that has a program where by running that program in a certain way, it might slow down the computer. That would be a denial of service attack. Sometimes you can do them just yourself. DDoS is a little bit more complicated. Let's see, what else do we have? Anything else? We get some interesting ones looking at problems with code. Let's take a look at a few of those and see if we can figure out anything interesting. Wow, a lot of people just joined that, that doc at once. What is the name for this? So this is a problem with C++ code. This is one of the reasons why C++ code is a lot harder to write than something that we would call a memory managed programming language, which is most modern programming languages nowadays. The problem with this is that we have to manually manage the memory. And so what we're doing here is we're actually creating a variable called username, and we're saying that it's going to be 32 characters long. And then what we're doing is we're taking the input from a command line program, and we're just copying it randomly into this username section, right? This username variable. The problem is, unlike most programming languages, C++ does not deal with arbitrary length strings. It deals with strings that are of the size that we tell them. In this case, we say it's a 32-character string. And so when we're just copying arbitrarily whatever was passed in on the command line parameter into the username variable, well, what happens if it's longer than 32 characters? Right? Yeah, someone pointed it out in chat. What if we just make the characters longer than 30? What if we just make it longer than 32 characters, right? And the answer is, on some operating systems have more protection against this than others, particularly on older ones, depending on how the program is set up, depending on what operating system you're running. In some situations, you can overwrite arbitrary memory, which is bad. Now, in almost all cases, you will be able to overwrite program memory. So that means, for example, if this is like a program like sudo, which on Mac and Linux lets you run things as administrator, that program itself has administrator rights. And its job is to check whether or not you are supposed to be able to get those rights, and if so, give you those rights. And in order to do that, it needs to have admin rights. So even if you're on a protected operating system, one that has some protection against overwriting any random memory, if you have a problem like this, a buffer overflow problem, in a program like sudo, you can still go ahead and get admin rights because you can overwrite, different parts of the program that are supposed to be checking it. You could overwrite the value of an if statement or something like that. But on operating systems that don't have certain types of protections, memory address randomization, data execution prevention, some other things like that, you can actually get really, really complicated into sort of messing with system memory that you're not supposed to be able to mess with. If you're really interested in this, there's a really great book called Hacking the Art of something. Let's see if we can find it. Hacking book. Hacking the Art of Exploitation. It looks like the art of exploitation. Apparently you can find a PDF of it online. Looks like this, or the orange one. The orange one I think is newer. This is a really great book that'll go into a lot of those sort of things, how you would set it up, and everything else. Lots and lots of programs that are written in C++ have some sort of buffer overflow problem, because it's really easy to mess that up. And sometimes people find them years and years later, even in open source programs, that there was a problem like that. So yeah, and someone sent out a link to an Amazon Smile link. So I don't know if that's for us or not, but maybe it will get us $1. So wouldn't be $1, it'd be like 10 cents. So that was a buffer overflow attack. Buffer overflow attack, again, a very common problem. By the way, another common problem you've seen in C++ programs, if you've ever heard of the concept of like a memory leak, you can get these in all programming languages, but they're certainly more common in C++ programming languages, which is that because you manually manage the memory, if you have a function that allocates memory, you say, I'm going to need a bunch of memory, and you forget to free it up, then you're going to have a problem, because every time that function gets called, your program says, I need this memory, and it never says I'm done with it, and so you eventually run out of memory. That's a memory leak, if you ever hear about that. It's possible to get them in memory managed programs like Java or C++ or C# as well, but certainly more common, maybe not even more common, but certainly a thing that happens a lot in C++. So that's that one. What else do we have? SQL injection. Here's a really interesting one. This is another really common one in beginner web applications. Okay. If anyone's ever seen PHP, anyone know what the problem with this code is? So even if you don't know much PHP, what we're saying is that this is a get parameter. So this is something like, where you usually would put like, HTTP example.com/test. By the way, this got an HTTPS, so it's totally secure, right? Nothing could possibly go wrong. That's not the case. Right, test, question mark. That's nice, it automatically puts a backslash. Question mark, what does this say? Username. Username equals Tyler Menezes, right? Now what's the problem here? Well, the problem is, this is the query that it's running, and it's sending this to the database. And it's just saying where username is equal to whatever the value was of username. Someone pointed out it's not sanitized. For anyone who doesn't know, we're going to just go through it. So we're going to paste this query in here. So usually the username would be something like Tyler Menezes, right? Or let's even say admin. And theoretically, you'd often see this with something like and password equals password, right? But let's just go with the simple case that we had here. So we have admin. Now what happens if instead of using the username admin, we use this really weird username called, so our username, rather than being admin, we use this username called single quote or single quote semicolon drop database users dash dash, which starts a comment, by the way. Well, what is it going to get inserted in here? It's going to get inserted in single quote semicolon drop database users semicolon dash dash, and again that starts a comment, so everything after it is ignored. Right? That looks like a bad query, right? That doesn't look good. So that's the problem with that code, is it's not sanitizing it, and you can do something called SQL injection. Here's a related one. So again, an example of how HTTPS is not secure. Oops, I want to load this in a web browser. So this is Python, just to show that this can happen in any programming language, because people tend to hate on PHP. Let's do this with test.py so we can see the syntax highlighting. So we have this URL, /showimage/source. So again, we're loading something arbitrarily from a variable, right? And in this case, it's the source. Now what happens, again, ideally what this is we can get rid of everything else. What this is going to do is it's going to render something that looks like this, right? and we're going to get a variable called source. Now what happens if this source variable is set to something like, usually this would be set to something like example.com/test.gif, right? What if instead we set it to something like single quote and tag script alert all your cookies belong to us /script and then let's just put like a dummy tag, so we'll put a div here. Well, what's going to happen, right? We're gonna say that we're gonna just copy this variable and we're gonna paste it over the source variable. Oops. We'll copy it this way so that we don't get the new line. We'll paste it here. What does this look like? I messed that up a tiny bit. This is not good. This is what's called an XSS, a cross-site scripting error. Not great. Now, in this case, we're just putting an alert, right? That's not terrible. We could be really annoying. We could put the alert in a while true statement so that you constantly get them, although most web browsers will let you cancel out of that now. But the other thing that you could do is you could theoretically get all of their cookies, which is what stores your login information effectively, and we could go ahead and send those off to some third-party web server. Now, there are other ways that people could protect against this as well, but it just goes to show you, again, if you're actually writing a web application, you always want to sanitize your stuff. And it's a common bug. It's something that you can come up with a lot. This one was an interesting one, by the way. This was a phishing attack. Zeke, who's actually in our chat right now, was a subject of a phishing attack in the last one. Basically, what you would want to do is you would want to get them to click on the link, and you would need to somehow get the content from it. Now, in the most recent one, we made it a little bit simpler. We made it so that when you clicked on a link, it would just email. If you got, for example, Zeke to click on your specific link, it would just email you the flag. That was the way we made it work in the most recent one. But here's this older one was actually, I think, a more interesting one. So let's see if we can take a look at it and see what we can do. And again, this is running on Heroku, so this will be a little bit longer. So you can see, if I zoom in, if you notice, it actually loads in, which is a good indication that maybe something is going on. And that something is, it's doing an AJAX request, which means it's using JavaScript to get a different file, and that file is /flag. So we can actually just load that directly. That's a good place to start. And you can see that's the text that it was loading in, right? And it was just displaying it. By the way that you would, I think that the way that this actually worked was I would just do /I and Phoebe. Yeah, there we go. And now you can see the actual flag, which, by the way, was hooked. So this URL is the thing that the flag is actually coming from. There's one really interesting thing about this URL. And we can find that out, again, in the network tab of this thing when we're looking at the headers, which is that it has this header right down here, access control allow origin. And I know that that's a little bit hard to see, so we'll go ahead and just paste it in here so that you can see it. Access control allow origin, *. What that means is absolutely any website is allowed to make requests to that URL. So theoretically, what we could do, and the way that this entire thing is set up, by the way, it would work if it's loaded from anywhere. So theoretically, what we could do is, as long as we can get someone to click on our link, any link we want, any link on a web page we control, what we could theoretically do as well is have it load this web page and then save it somewhere using JavaScript. And if someone like Phoebe were to click on it, then it would give you the flag, which again is hooked, rather than the one that would show up for anyone else. Which is, flag would be here, but you're not Phoebe. So that's cross-origin request sharing. Again, it's something that is, usually by default, browsers won't let you request websites from different domains, unless they say that they're allowing it. But in some cases, people will like misconfigure their web server or something else, which is again bad. Okay, I think we have time for one more question. Anyone have any specific requests in the chat? Any specific requests for any questions that you thought were really cool in previous Code Cups that you didn't necessarily see solved, or just any, if you've heard of something in hacking and you're not entirely sure what it is, feel free to post those as well. How do you do the dog images one? Do you happen to remember which Code Cup that was? Like what season, which Code Day season it was? I'm gonna see if I can find it. If I can see if I can find any images one. Winter of 2017. Oh, okay, 2017. I do not have a record of the questions for 2017, unfortunately, because it's just like we don't have it. No one thought to save it at the time. It wasn't something we were doing regularly. I could show you how images ones commonly work. The way that you'll really commonly see image questions coming up in capture the flag like things, and it's actually a way you can hide information in an image yourself. So let's actually go back to the screen because it's still interesting. So let's find an image of something we want to hide it in, and I'm actually going to use one of my favorites, which is I can actually post it in Twitch chat. It is One Hand. It's a global Twitch emote. Whoops, go back here. Global Twitch emote, One Hand. It's actually Edward Jang, who's the founder of SR&D, used to be a Twitch admin back before it was called Twitch. So if you've ever wondered what the One Hand emote is, that's actually where it comes from, is the founder of SR&D. But we will go ahead and find, let's just go to just the screen, One Hand, Twitch. By the way, the reason it's called One Hand is because his username was Edward Starcraft. Actually came up before. His username was Edward Starcraft, and you could type Edward Starcraft with one hand, which is just kind of an interesting fact that people found out and were excited about. This is a terrible quality version, but we're going to go with it anyway. So we're going to save this. We're going to save it as onehand.ping. And what we're going to do is we are just going to put text at the end of that image. So what we'll do in Linux, this is a simple way I can do it. Echo hello. This will work in Mac as well if you have your terminal, but I don't think it'll work in Windows. So we'll put, let's say, Edward Starcraft. I guess there's no space there. Edward Starcraft, and we will just put it at the end of a file. Putting 2 arrows afterward means concatenate to the end of file after this. And our file is called onehand.ping. Can you type it with your nose? You also can't type it with one hand on Dvorak, which is the keyboard layout I use. So what we'll do now is we will run Fe, I think, which I have, which is a default image editor in default image viewer in Linux, and you can see the image still loads, right? I can open it in GIMP as well. It'll take a second. Let's put it over here. You can see it still loads, but if we run, what was that really magical program for binary files? If we run strings on onehand.ping, you'll actually see a bunch of nonsense that just happens to look like strings as far as strings is concerned. And at the very end, Edward Starcraft, which is interesting. And by the way, you can put arbitrary data at the end of any image, zip file. I think you can even do it with executables. Most binary formats will just, if you put things at the end of them, not in the middle, but at the end, they'll just ignore anything that they're confused about and just like completely ignore that it's there. So you can actually put, for example, a zip file at the end of an image, which is another common thing that you'll use. Now, how do you get the zip file out of the image? That's a little bit more complicated. There are some tools for it. The other way to do it is you have to look for, like, every zip file starts with the same 2 letters, I think. So if I, like, zip this, every single zip file is going to start with, that's not helpful. I don't know what that is. Oh, interesting. I actually do know what's going on. Vim actually knows how to process zip files. That's kind of cool. So you can see we got all this stuff. We'll do head, so we see just the front. And we can see that every single zip file, for example, I think starts with this nonsense here, which again is not actually helpful, but you know, this is this is the start of the zip file. So you can actually, you could look for something like this, split up the files back into two, and you could do stuff like that. So that was how most of the image questions that we've ever had, that's how most of them have worked in the past. So we're gonna go ahead and go back to these things. So someone was asking in the chat, we'll go to Q&A. I got about 5 minutes left to go ahead and answer some of these. And then if you have more questions, again, chat.srnd.org, SRND being the name of this channel. Just add chat dot to the beginning of it and replace the underscore with the, you know, with the dot. If you're just joining us from Twitch and you have no idea what we're about. We're free to answer more questions there as well. But if you do have any other questions in the meantime, feel free to chime in. I got about 5 or 6 minutes left. Someone earlier, DGWERLOD, I have no idea how to pronounce that, asked, how do you do real hacking? Yes, I am very proud of you, Zeke. So someone asked earlier, how do you do real hacking? Really, the way that you hack things is you try to figure out how they work. That is the first step. And so the image ones are actually a little bit more artificial. They're just more of an interesting thing. But things like decompiling executables, how do you think that you make a keygen, right? That's actually a problem we've had yeah, well, no, I mean, I know that was kind of a joke, but I think it's an interesting point. How do you make something like a keygen, which is something that we've actually had as kind of a problem in a previous CodeCap? How do you break websites? How do you hack websites, right? All of it is about trying to find things that people might not have done properly. And a lot of these problems, even though they're really, really basic examples of the problem, they come up in more complicated ways. And sometimes what you end up having to do is chain things together to make them really work out in a useful way. Where you can actually do things. And so oftentimes you'll end up with someone like chaining 3 or 4 different exploits together to get something that actually does something useful. So, I mean, that is really how you do hacking, is you just poke around at things. And that's also why the term hacking really applies there, and where the term hacking, a lot of it originally came from, is messing around with stuff. Trying to figure out how things work. And once you know how they work, then you can figure out how to break them. And at the same time, once you know how things work, you can also hopefully not make the same mistakes on your projects, which is really the ultimate goal of any of this, is to make sure that you're not making these mistakes. With that in mind, I think we're going to go ahead and close this up. But again, if you have any more questions, feel free to join chat.srnd.org. Tomorrow at, I believe, 4 p.m., we're going to do a workshop on making your own circuit boards, which does not mean breadboards, does not mean Arduinos. We are literally going to design and order printed circuit boards that look very professional, and they will be your own design, and it'll be super, super, super awesome. You will come out of it spending like $3 and coming out with a circuit board that will actually be delivered to your house. I think we'll get 3 of them. Be delivered to your house from hipsters in Portland. So that'll be tomorrow at 4. Next week we have a bunch of awesome workshops on our schedule. Let me go ahead and pull up our schedule so I know what's already scheduled. So next week we have a workshop on Unity. Game development, basically we have a workshop on HTML and CSS if you've never made a website. We have a workshop on Docker. If you've never set up a server and you don't want to set up a server, but you still want to have the benefits of setting up a server, Docker is a great way to do that. We also have a workshop on setting up a web server program, writing a web server program in Flask, which is similar to that Python web server that we looked at earlier. So all that is coming up next week. If you are in CodeLabs this summer with us, or you're in the SRND chat, you'll get both email notifications and chat notifications. So do put those on your calendar. Make sure that you're there to check them out. It'll be a lot of fun. And if there's anything you want to see in a future CodeLabs, go ahead and let us know that as well in the chat room as well. And we're happy. We still have some room on the schedule to add a few more workshops in the evenings. So do let us know. And other than that, hope to see you in the chat, and hope to see you tomorrow for the last workshop of the first week. So thank you.